Hey guys, welcome back to the channel. I am here to make mathematics your superpower by doing everything in my power to make the complex very simple. Now, speaking of complex, this is a complex fraction which is a CXC type question, or if you're in fourth form, you may encounter this on your end of year exam. This is part 2 and we're going to be converting mixed numbers to improper fractions and vice versa. Before we get into all of that, I want you guys to have a visual representation of what a mixed number is and also an improper fraction. So here we have a few purple blocks. Each block is divided into 3 parts. Alright, so now for the mixed number, we have a whole number component and we also have a proper fraction where the numerator should be less than the denominator. Alright, so for the whole number component, that should be the total number of blocks that are shaded. Alright, and here we have one block which is 3 out of 3 and another block. So we actually have 2 blocks that are completely shaded, and so our whole number component is 2, representing 2 sets of 3. Alright, for the proper fraction component, we have a numerator of 1 and a denominator of 3. So for this last slab of blocks, we have 1 out of 3. Alright, and that's it for the mixed number. For the improper fraction, we need a numerator and a denominator. The denominator remains the same since each block is divided into 3 parts. As for the numerator, this is represented by the total number of shaded blocks. And as we can see, that would be 2 sets of 3 plus an additional 1, which is 7. Alright, so I want you guys to note the pattern that the denominator doesn't change. It is the same in both cases. And also to achieve this numerator, we have 2 sets of 3 and then we add that 1. Alright, so let's look at the formulae and do a few examples. I want to break here to also say, just in case you want to practice, there's a link in the description that will take you to a quiz where you can practice after you have watched the video and you feel as though you are comfortable and strong in this conversion. Alright, so let's begin. So we want to copy that denominator, step 1, because it remains the same as you can see from the formula. As for the numerator, we want to multiply down and then add up. So we have 12 sets of 6, which is going to be 72. And then we want to add up, which is going to be our numerator here. So we have 72 plus 2. Alright, and that's equal to 74 over 6. Number 2, again, we want to copy that denominator. Now we multiply down, which is 10 times 4, and that's going to be 40. And then finally, we want to add up, which is 40 plus 1. So in total, we have 41 divided by 4. Alright, and for this last question, again, we want to copy the denominator, multiply down, which is 7 times 8, 56. And lastly, we want to add up, which is going to be that numerator of 6. Alright, so our final answer is going to be 62 divided by 8. And that is it, guys. The steps are very simple. Please go ahead and pause the video. Take the time to practice using the link in the description. Alright, so for the part 2, we're changing now from an improper fraction to a mixed number. We want to go ahead and copy the denominator because it never changes. Now for the quotient or the whole number component, we're going to ask ourselves, how many sets of the denominator can I get from the numerator? How many sets of 2 are in 19? And that's going to be 9 sets of 2. Now, 9 sets of 2 means that we're not quite there to 19. We have a remainder of 1. Alright, for number 2, again, we copy that denominator. It is the same, so we're using that 3. Then we say, how many sets of 3 can I get from 14? That's going to be 4 sets of 3. 4 sets of 3 gets me to 12, so I have a remainder of 2, and that's going to be my numerator. Lastly, we want to go ahead again and copy that denominator. Then I ask myself how many sets of 9 are in 67. That's going to be 7 sets of 9 with a remainder of 4. Alright, and so that is it, guys. Thank you so much for watching. Come back for part 3, where we'll be adding and subtracting fractions with the same and different kind of denominators. Alright, and then we have the use of calculators and so on as we go along. So have a good one.